All right, so welcome guys to econometrics. Sorry, I just didn't give us enough time to chat a little bit before the session starts, but it's okay. We haven't got much to do anyway here. So we are going to be doing today hypothesis testing and statistical inference. Right, we are going to be looking at this here. So we have this briefly in the assignment, and we have this again pretty much in every exam that you're going to write here. So this is important, right? So we are going to talk about, in any case, what is this hypothesis testing that we are going to be doing here, right? Which is something that you probably have done before, but bear in mind that we are doing much of theory, so much of explanations here, much of explanations than calculations, a few calculations, but more of the explanations of what we are doing here. Keep that in mind. And then the t-test. Last year, when we were particularly doing this, I think I went into detail about what the t-test is really, who came up with the t-test, under what conditions must we use the t-test, but it's really unnecessary here for econometrics, right? We don't need all that information. We just need to see where we apply the t-tests there. And then, of course, the limitations of the t-tests, right? What are confidence intervals again? Right, we are going to be talking about that there. And then, of course, the overall test, which is the F-test. That's what we are going to be looking at. So once we are done with this, then we'll be diagnosing econometric problems, right? We'll be busy diagnosing econometric problems until the end of our module, right? So, right, let's let Mchabiseng in, and then we start our session. All right, so what is hypothesis testing? So in the light of what we are doing here, in the light of econometrics, we are going to be discussing this here in that line. So what have we learned so far? The gist of it all that we have dealt with, we are trying to investigate a relationship between two economic variables, right? This is what we are doing. And then we express that relationship in terms of an equation, right? An equation which is going to be in the form of y is equal to mx plus c, right? So which is our regression model, right? So because it's a scatter plot, we are using a sample. We do not really expect a perfect straight line relationship between these two models. So we use the scatter model, but we are basically not the scatter model. Let me say we are using the regression model, right, to estimate the relationship between those. So eventually, in estimating that, we use the ordinary least squares method. So we spoke about why we are using the ordinary least squares method in the last session. Why that method? Right? We spoke about that. We're talking about it. Of course, yeah, we're talking, right? We're basically talking about how a good regression model needs to be blue, right? It needs to be blue. Remember that abbreviation there, which I say is very important, blue, right? Best linear unbiased estimate, right? So we went into detail about what those are. So you just need to go through those again and check what that means there. All right, so we use the OLS to basically estimate our parameters, right? Our regression parameters, our regression estimates, right? We use that to estimate that. So what are those estimates? So we normally have the constant term, right, which is our beta naught, right, which is our beta naught there. So what does that represent? The beta naught there basically represents the line where our regression, if you're going to be looking at if you're basically going to be looking at two variables there, the constant term basically represents the point where your graph or your line is going to be crossing the y-axis there. So in other words, when your x is 0, what is the value of y? And by the way, in case you missed this on the first sessions, we have what we call y variables and x variables, right? Y variables are the variables that we want to explain, right? So these are the dependent variables. So which are the ones that we basically want to explain the movements, changes in that variable. It's what we want to explain. So how do you want to explain those? Sorry. How do you want to explain those? We want to explain those using what we call independent variables, which are the X variables, the explanatory variables, right? So that's what we have done so far. So hypothesis testing now, this is where hypothesis testing comes in, right? So hypothesis testing, I'm going to be here now, written from there, right? Hypothesis testing goes beyond calculating estimates of true population parameters to a much more complex set of questions. So we are going to be looking at those complex set of questions, but because now we have mentioned true population parameters, let's just bring that to perspective again. So we said in regression analysis or in econometrics, we really can't measure, or we don't have access to the population, which is in terms of the whole population. We don't have access to the whole population. And as a result of that, we make use of samples. So which means on the one side, we have a true population, and then on the other side, we have a sample, right? We make use of samples. So the true population is what is true, right? So in other words, so if you estimate, or in other words, if you come up with beta coefficients, right? Those coefficients, those estimators, if you come up with those coefficients for the true population, they will basically give you a true relationship between the two variables based on the population, right? So the population is the whole. So once you test the whole, you will basically have a true relationship between two economic variables. But because we rely on samples, right? Samples can either be, remember the beginning of econometrics, so we spoke of 3 types of data, right? Cross-sectional. We also have, what do we have? Check those ones out, right? The types of data that we use here, right? Just recheck that. You'll probably get a question on that. Cross-sectional data, you also have a time series, and then you have got one, which is basically a byproduct of those two, right? So if you're gonna look at, say, a time series, you are measuring interest rates against the GDP, and then you are dealing with time series data. You can't measure the whole population, right? You can't really measure the whole population because you don't have all that data. So you are gonna take a sample, let's say from the year 1990 up to the year 2020. So that basically represents a sample, right? So you can basically estimate the relationship between those two economic variables based on that time frame there. So you obviously don't have data for what happened in the 1900s. Right? Shakespeare, you don't have that, right? You don't have that. Christopher Columbus, Shaka Zulu, you don't have all that information, right? So hence, you don't have the true population, but we rely on what we have, which is a sample. So at the end of the day now, hypothesis testing and statistical inference. Now, 6 to C, all right, no, let me not put the cart ahead of the horse. Let's go step by step here. So hypothesis testing and inference allow us to answer important questions about the real world from the sample. So at the end of the day, we have a sample now, and then what did we do? We came up with parameters, beta coefficients for that sample to estimate a relationship. That's a sample. So hypothesis testing now and statistical inference is basically gonna help us answer certain questions with regards to the real world from the sample, right? So it is likely that our results could have been, so is it likely that our results could have been obtained by chance? Those are some of the questions that we will get answered, right, from the hypothesis testing though. Because, sometimes there is a likelihood that, certain variables move in a certain direction by chance, right, purely by chance. So you can't base a theory, on chance, on an event that occurs once in a while, right? You really can't base on that. So we need to assess that now using statistical inference, whether the occurrence of that is by chance or not. You see. So in other words, we are still talking about the relationship between two economic variables. So are we saying when the interest rates went down and the GDP went up, could it have been by chance, right? Or is it something that is bound to happen over and over again? See, so if it's by chance, then you can pretty much expect that next time when the interest rates go down, maybe the GDP is also going to go down. See, so that could explain that, okay, last time when this happened, it was by chance, but How do we find that out? Then we need to do a hypothesis testing on that, some statistical inference on that thing to see whether or not it's by chance. All right. So remember, this information that you are gathering here, you need to hand over this information to somebody that's going to make decisions, right? That's going to make certain decisions that affect a lot of people. So we need to answer these questions. So will the results generated from our sample lead us to reject our original theories? So you have theories. Remember the previous session, we said the starting point of this here, of coming up with a good model, you need to read the theory around, right? Find out what are the expectations, right? So are you going to reject theory, or are you going to still stand with theory? Yeah. So if you look at, I think the example that I gave last time on this, if you look at a normal good and a given good, for instance, a normal good, what happens when a person's income goes up? We figure out that a person's demand for a normal good is supposed to increase. But you do some testing, or you do some tests, right? And then the result goes the other way around. So how would you explain that now? How would you explain that? So that's a given good now, where the income elasticity is negative there, right? Where a person's change in income results in, say, a person's increase in income actually results in them demanding less of a certain product. So we say those are given goods, right? An example of those are given goods, goods which are not normal. So suppose you're doing a hypothesis testing on that, and then you came across those results there. What would you do? So now you'd most likely now want to reject the original theories in terms of what happens when a person's income increases and it's a normal good, right? So you would probably want to reject that there. But is that the case? The best thing to do is to read more, right? And find out if you are dealing with the same goods, for starters, you see? So this year I'm just saying now to imagine the first person that discovered that, what went through their minds after conducting some empirical tests on that, you see. So sometimes you might want to reject the whole theory, or sometimes you want to do further studies and see maybe you have a new theory now. How confident can we be that our estimate is close to the true value of the parameter? You see, how confident are we? Hence, we talk about confidence intervals, right? There's a theory on that, by the way, but we don't deal with those theories much. So hypothesis testing and the t-test should be familiar topics to readers with a strong background in statistics who are encouraged to skim this chapter and focus only on the applications. Right? So we are basically going to be doing applications anyway. But in any case, let's just jump through into hypothesis testing there. All right, so this is interesting. Let's look at hypothesis testing being used in a variety of settings, right? Let's say the Food and Drug Administration, which is the FDA, for example, tests new products before allowing their sale, right? If the sample of the people exposed to the new product shows some side effects significantly more frequently than would be expected by chance, then the FDA is likely to withhold the approval of marketing that product. So if you look at a drug, for instance, when we are putting across a drug to the market, a drug like I think we had these COVID vaccines. Let's talk about the COVID vaccines that we know of recently. So before they give that out to the public, they run tests, right? I think if you were following social media at that time, people were very much critical about that whole vaccine. Why? Because of this that we are discussing here today, right? It's the reason why people were very critical of that thing. So why is the case? So the FDA is supposed to carry out tests on the new products, and normally for a vaccine, you don't test the vaccine overnight and come up with the results. Why? Because sometimes there are certain long-term effects, right? I think I was reading the one time about cigarettes, the history of cigarettes, right? I don't know if you guys spoke, but I'll just give you a history of cigarettes. Back in the day, when cigarettes were relatively new in the market, if you didn't know, cigarettes were basically marketed as headache stoppers, right? They would basically say, or a pain is, whatever the case is, but they were basically marketed for the most part as something that can help you, that can help relieve you of a headache. So they'll put adverts like, if you wanna get your head, like if you wanna get rid of a headache, get yourself a cigarette, etc. So those were the marketing strategies that were prevalent in that time, during that time, you see. So they were basically saying nicotine is very good for your health. Nicotine is very good for stopping things like headaches and the likes. So over time now, people died for many reasons, like people always die. So what happens now is when people die, we do, or they do what they call an autopsy, right? To try and examine what were the causes of death, right? So they were doing autopsies. So obviously, if you look at the consumption of something like nicotine, you can't expect to have results, say, within the first 50 years or to 100 years. You're probably not going to get results that you want for that, to examine what exactly could be the reason why people are getting so much, maybe nicotine related diseases. See? So in other words, what am I saying? We need to have a sample, right, of dead bodies. Not just a small sample, but a big enough sample for us to come up with a conclusion that, okay, nicotine has got such and such side effects, you see. So you don't just test one person and say the vaccine is approved. So it's the same thing that they do with vaccines. So they take a long period of time for vaccines to be approved. So you run tests. So in other words, those tests, it's a sample. So you get samples of individuals. Sometimes it's not really, looking at consumption of nicotine, which is the cigarettes, right? The consumption of cigarettes. So this is specifically going to be done on actual bodies. So you are going to be examining actual bodies of people who have died to see how related are the causes of death to their nicotine consumption, you see. Now they've got what we call the rat labs, right? Which they basically run those vaccines on those rats, because I think the rat system is pretty much similar to that of a human being. So they see how the vaccine responds with a rat, and then they can draw a conclusion about how that's going to respond to people. But at the end of the day, rats are rats and people are people. So at the end of the day, you must have run sufficient tests, right? You must have run sufficient tests. You also don't just test one rat. You test a couple of rats, and then you examine a relationship now between the consumption of a certain drug and a certain health effect, right? A certain health effect. So I say this to say this now. The sample has to be reasonably large. So if you look at, say, something like happy that we love so much, it's harmless, right? From what we know, it's harmless. But how do we know it's harmless? We haven't done good enough samples on that. So we need to gather up piles and piles and piles of bodies, then we can then see whether or not it's harmless, right? Because most of the people that have been consuming happy haven't died, right? Something that is relatively new, you see. So this is what the FDA basically does now, the Food and Drug Administration. That's what they basically do now. They want to make sure that before a drug or before anything is released out there for consumption, a reasonable amount of tests have been conducted. So this is what the biggest gripe was over the COVID vaccines. People were saying these haven't been tested long enough. You couldn't have developed a vaccine within a period of a year, right? How has it been tested? How do you know if there are no long-term effects, long-term bad side effects for that matter? So that was the gripe for that thing. So we're pretty much on the same page with those people as students of statistics, right? We're pretty much on the same page with that thing. So similarly, economists have been statistically testing various relationships between consumption and income for almost a century. So theories developed by John Maynard Keynes, got a Nobel Prize, by the way, for that, and Milton Friedman, among others, have been tested on macroeconomic and microeconomic data sets. So at the end of the day, these guys came up with theories. So we need to test those theories now, right? Based on what? On actual data sets, which are samples, right? So now we just don't know now if our samples are long enough, because you have a look at some of the theories that John Keynes had could have been just applicable during the Great Depression, right? Which is why maybe Milton Friedman would disagree with what John King said. So which is now the aspect of, back to the aspect of sampling now. What does your sample include? Right? What sort of periods are you incorporating there within those samples? Because now, like John King's, you can basically take a sample during the Great Depression and then you come up with economic theories on that. But are those theories going to be applicable during an economic boom? You see. So ideally, you must have a sample that's going to cover through all the basic economic cycles so you can have a reasonable conclusion there. But again, I must say it depends on what you are testing, right? Sometimes you're only testing data during a Great Depression so that you can come up with theories of how nations can basically pull themselves out of a Great Depression. Sometimes you're looking at economic boom, sometimes inflation, whatever the case is, right? So although researchers are always interested in learning whether the theory in question is supported by estimates generated from the sample in the real-world observations, it's almost impossible now to prove that a given hypothesis is correct, right? You can't prove that, right? All that can be done is to state that a particular sample conforms to a particular hypothesis, right? So we've tested the sample, so we can only prove that, okay, this is basically conforming to the theory. So even though we cannot prove that a given theory is correct using hypothesis testing, we often can reject a given hypothesis with a certain level of confidence. So this is what we are going to be doing there. All right, what then is the null hypothesis and the alternative hypothesis? So you are going to go big on this, by the way, in the exam. So null hypothesis typically is the statement of values that the researcher does not expect, right? So you are going to be asked in your assignment to come up with a null hypothesis in symbols and in words, right? You are going to be asked that, which is very, very, very simple. So the starting point is it's a statement that you are not expecting, right? It's a statement that you do not expect. So for example, if you expect a positive coefficient, so to bring this to context, when we talk of a positive coefficient, we're basically talking of a positive relationship between these two variables. So we expect that there will be a positive coefficient there. So an example of a positive coefficient would be when you are examining the relationship between the quantity supplied and the price, right? So you would expect a positive coefficient. So which means, what will your null hypothesis there be? Then you would say your beta coefficient is less than or equal to 0. So which is what you do not expect in terms of the supply curve, right? You expect that the supply curve, your beta coefficient is going to be above 0, which is positive, right? So which means you put what you don't expect there as the beta is less than or equal to 0. So which is, in essence, you're saying it's either 0 or negative. So under what circumstances is your beta 0? It's 0 when there is no relationship between those two coefficients. So you do not expect that either, right? You expect a relationship. What kind of relationship? A positive relationship. So that's the null hypothesis. Then the alternative hypothesis, then it's obviously what you expect. So you would expect a positive relationship there between your quantity supplied and price. So that's given there as your beta being greater than 0. So that gives you a positive there, right? So what is a one-sided test now? So a one-sided test is basically what we have dealt with now. So where you are saying it's either negative or positive, right? And then which means, sorry, let me not put it that way. Now it's going to look like a two-sided test. So a one-sided test is basically saying we are expecting that one sign or the coefficient sign is a specific sign, right? It's either negative. It can either be negative or it can either be positive. So you're expecting that it's not both at the same time, right? We are basically expecting that it's a given sign and it's one sign. So same as what we are dealing with here in terms of the supply curve. So we know that it's either, we are saying it's positive. All right. What then is a two-sided test? So under a two-sided test now, we are dealing with a situation where the relationship can either be negative or positive, right? It can go either way, right? So which means what we don't expect now under these circumstances is that there is no relationship only. But we can expect that the relationship is positive or negative, right? It's like if you're let me think of a good example. Okay, I can't really think of a good example, but let me say where this is normally applied when, let's say, if you are not sure of the relationship, of the expected relationship. Remember when we were doing the previous session, we said part of the steps in coming up with a good model is hypothesizing the signs, right? What are the expected signs? And then you can say, okay, this is what I expect. I expect that the relationship between this is going to be positive. So which means your coefficients, you're going to be expecting a positive sign. So if you have got no such expectations, but because you're looking at two economic variables, you're basically saying, I know there is a relationship between these two variables, but what is it? It can either be negative or positive. So under those circumstances, then you do what we call a two-sided test, right? So let's just assess that again in passing. So your null hypothesis, which is the values that you do not expect, we are saying you do not expect that your beta is equal to 0. So in other words, you do not expect that there is no relationship between the two variables. That's what we are saying in essence there. And then the alternative hypothesis, now you are saying you expect that beta is not equal to 0. So in other words, beta can either be greater than 0 or less than 0. So it can either be positive or negative. That's what we are basically doing there. Okay, maybe let's look at this example there. All right, now let's pick it up from here. Type 1 and type 2 errors. I like this example here. All right, so typically, testing techniques in econometrics is to hypothesize now an expected sign or value of each regression coefficient except for the constant term, and then to determine whether to reject the null hypothesis testing. So this is where we are going to be doing the two testing. This is also there in the assignment. So you are going to be testing each and every one of those coefficients, deciding whether or not we are going to reject the true null hypothesis or reject the null hypothesis or accept it. Right. So let's look at what happens in practice, in law. Right, in law. So there's a presumption now in law that a person is innocent until proven guilty. Right. So when a person is brought to trial now, so the presumption is you are innocent until you are proven guilty. Right. So when a person is brought to trial, right, what's the null hypothesis now? So we are saying, in other words, what we do not expect is that the defendant is innocent, right? That's what we do not expect. If you look at, there's Thabo Bester now, there's this case, I don't know if you guys are following that case now. If it's going to be taken to court, of which he is going to be taken to court, what is it that you do not expect? So the fact that it's being taken to court now, we do not expect that he's innocent. So the null hypothesis there is that the defendant is innocent. That's what we do not expect. And then the alternative is that the defendant is guilty. Right? Those are the two there. So which is what we expect there. So we'll talk about what happens there now in relation to type 1 error and then type 2 error. To the jury to be convinced beyond reasonable doubt. Right? It's up to the jury to be convinced before reasonable doubt that this client, suppose you are a lawyer, right? It's up to you need to convince the jury beyond reasonable doubt, right, that your client is innocent, right? So in other words, for them to not reject the null hypothesis, right? For them to not reject the null hypothesis. They need to be convinced beyond reasonable doubt then. All right, so let's talk about what type 1 and type 2 errors are there. All right, so what type 1 and type 2 errors are. Just give me a second, sorry. All right, what those two errors are. So most of the questions that we will get with regards to type 1 and type 2 errors is basically a definition of what's going on there. Type 1 error is we reject a true null hypothesis, right? We reject it. So what is the null hypothesis? So we already mentioned here that a null, if you look at a null hypothesis, you're basically looking at values that you do not expect, right? Values that you do not expect. So in other words, something that does not go along theory, right? So in other words, when you reject that now, it's type 1 error. So you're rejecting a true null hypothesis, so which is something that you're otherwise saying it's false. So we refer that to as type 1 error. All right. What about type 2 error now? Type 2 error, it's an instance now where you do not reject a false null hypothesis. So in other words, you accept the null hypothesis as true, right? But the wording here that we use is specifically wording that is, I mean, you know, that is normally used also in law language. You do not want to put yourself into trouble there. And so let's look at the circumstances now, why this is coming up. So let's start it off from there. So since regression coefficients are only estimates of the true population, this we have mentioned over and over again, right? It will be unrealistic to think that conclusion drawn from a regression analysis will always be right. So if you look at a case like O.J. Simpson, a case like Thabo Bester that we're gonna have now, even who's this popular athlete, Pistorius Oscar. At the end of the day, we are looking at a balance of probabilities there. It depends on how much evidence has been brought forward. You see, so we are basically, the jury is deciding according to the amount of evidence that has been brought. So in other words, the evidence they can represent the sample. You see, but it may not be the case, right? It may not be the case. Sometimes someone could have killed someone. That's the true population, to put it that way. But because no one was there, there is no evidence. So in other words, the sample makes us to draw different conclusions. Like maybe the sample is wrong. You could have obtained, maybe he has an alibi where he says he had a friend during that time. So that evidence basically represents the sample. So according to the sample, the jury comes up with a conclusion and they say maybe he's not guilty or he's guilty. But at the end of the day, I mean, you've read of cases where people have been falsely accused and imprisoned. You see. So these issues are what we call type 1 and type 2 errors there in terms of law. Right. So if for instance, okay, maybe let's just proceed with that there. So we are saying, based on the sample, we have come up with parameters, right? We've come up with sample parameters. We have come up with coefficients to estimate a relationship. So we are not saying that that is actually true, right? We are simply saying, based on the sample, these are the conclusions that we arrive at. Right? So there are two kinds of these errors now. Type 1, we said we reject a true null hypothesis. So in other words, we are sticking to and then the other one is going to be type 2 error, where we say we do not reject the false null hypothesis there. So let's look at the situation in terms of what's happening there in law. So our expectations now is that the defendant is guilty, right? So that's the alternative hypothesis. And then what we do not expect is that the defendant is innocent. We have that there. So what will be type 1? What will type 1 error be in those circumstances? So which is rejecting a null hypothesis, which means sending the defendant to jail, right? So it means that we are sending the defendant to jail, but the defendant is innocent, right? We are sending the defendant to jail, but this guy is innocent. But what is type 2 error? We are freeing a guilty defendant. Yes, that's what happens. So in other words, if you look at that, there is the null hypothesis there. So if we are rejecting the null hypothesis, then we are rejecting that we are basically saying he's guilty, right? So we are rejecting the null hypothesis and we are sending this person to jail. But what if that person is innocent? So if it's the case that the person is innocent, so in other words, if we are at odds with that there, then we refer that to it as the type 1 error, and then the other one will be the type 2 error when we are freeing a guilty defendant. Now, I need you to notice one thing now in terms of the decision rule there, right? In terms of the decision rule. Ideally, we want to minimize type 1 error and type 2 error, right? We want to minimize those in any circumstances there. In other words, you don't want a situation where you are sending an innocent person to jail, neither do you want a situation where you are freeing a guilty defendant. So you want to look at your probabilities there, right? So most reasonable jury members would want both levels of errors to be quite small, but that is impossible. Why? Because whenever you want to reduce the probability of type 1 error, you are increasing the probability of type 2 error, you see. And then if you want to reduce type 2 error, you are increasing type 1 error. So it's always the case there. So in simple terms, decreasing the probability of type 1 error, which means the probability of sending an innocent person to jail, means that you are increasing the probability that you are going to be freeing a guilty person, you see. So that's a dilemma there that we have here in statistics and in doing our tests there. So how do we then come up with these decision rules? So we have what we call a critical value, right? We have what we call a critical value. So a critical value would be like the 50% pass mark. It should be something like 50% pass mark, where we need to, run our conclusion now and say if this goes beyond 50%, then the student has passed. If it goes below, then the student has failed. Right. Let me just connect my phone. My battery is low. All right. My battery is low. Before it switches off. All right, and then the critical lower that we accept or reject them. So we already say it now that, so at the end of the day now, okay, if you look at, let's look at this example here. If you look at, say, when we want to use a decision rule given a critical value of, say, 1.8. So if we observe that our coefficient, oh, okay, Wilna is going to be out anytime. All right. If we observe that our coefficient now gives us a value that is greater than 1.8, we can reject now hypothesis now. Then we can conclude that beta is 0 or negative, right? We can basically come up with that conclusion. So the thing is now, if our observation goes beyond the critical value, then what do? We reject the null hypothesis. So in other words, we stick with the alternative hypothesis. So let's say you are looking at passing and failing, right? The critical value is 50%, right? So if based on the sample now you have written an exam and then you've gotten what? You've gotten, say, 60%. So what do we do if you get 60%? What do? We reject the null hypothesis, right? We reject the null hypothesis. So in other words, we are saying that the student passed. So you made it. So this is what we are doing there. All right. So we now have got two regions now, which is the rejection region and acceptance rejection, which are the acceptance region there. All right, so bear in mind what we already said here, right? Where we say, I want to talk about the, right here. Unfortunately, decreasing the chance of type 1 error means increasing chances of type 2 error there. So we already mentioned that there. So this is what it looks like now in a diagram, right? So we have got that 1.8 there, which is the pass mark, in other words, there, which is our pass mark, right? So which means, let's look at, okay, let's drag it down there. Okay, no, we do have it there. So where we have type 1 error, so I'm just gonna take you back there again so that we see what type 1 error there is, right? Which is the probability of type 1 error there. So we wanna keep that small there. So you can see it's kept at small. So which means type 2 error is the big one there. So this is our critical value now. This is our critical value, 1.8. Right. So if it goes beyond 1.8 there, what do? We reject the null hypothesis. Right. If it goes beyond 1.8, we reject the null hypothesis there. So where does this 1.8 come from? So this 1.8, as we're later going to see, determined by the level of confidence that we have. So which means, all right, no, we will just examine it later again. So if it's a one-tailed test, this is what it's going to look like. So you just have this written there where we are saying once it goes beyond 1.8, a positive 1.8, then we are going to reject the null hypothesis, right? Then if it falls short there, then we are going to basically accept, fail to reject. So we use the word fail to reject the null hypothesis there. Then for a two-tailed test, this is what you basically have there. So in other words, you're going to have two critical values there, negative and positive. So probably if we're using 1.8, you would have a negative 1.8 there and a positive 1.8. So if it falls over 1.8 in the positive, what do? You reject the null hypothesis. Then if it comes again, falls below, in other words, if it's 1.9, etc 1.10, then again, you reject there. So anything within that range there, you would basically accept the null hypothesis there. All right, so which takes us now to the t-test, what we do on the t-test. So for you to carry out a good t-test, what do you need? Or for you to carry out a proper t-test, you basically need the coefficient, number one. But you basically need a coefficient there, which is the beta coefficient that you are testing. And then you also need standard error. So you are basically going to be given those there. So this here, the border value is normally given there as 0. It's always going to be given there as 0. So which is why we don't normally include that thing. All right. So what is beta there for the kth variable? So it's estimated regression coefficient. So you want to test this coefficient. Basically, that's what you're doing, and then you're going to be using the estimated standard error. So that is the square root of estimated variance distribution there, right? Then note there is no head attached to the standard error because the standard error is already defined as an estimate. Okay. So this is basically what you're doing there. So let's look at that in practice. I'm not sure if I have the assignment question open there. All right. So what do we have now? So whenever you are going to be given this now, so these are the questions. I think you have something similar to this in the assignment there. You are testing these coefficients there. Right. You are testing these coefficients there. How are you testing that? You are going to be dividing these coefficients by the standard error. So these are the standard errors there. And then these t's here, these are the critical values. Then you are going to be measuring that there against the critical values there. Let me see if my calculator shows. Okay, the calculator doesn't show there. All right, maybe let me do a new share. Let's share the screen. Right. Right, because I want to do a calculation there. Right? So if you look at that amount there, so what's the coefficient of n, right? Whatever that n is. So we are just going to skip naming those things there. But basically, your explanatory variable or your x variable there is n, right? Your other one is p, your other one is I. So we want to basically do a test on that. Just going to show you how we do the test. You will see how easy it is. So I said there are calculations here, but very few calculations. So these are some of the few calculations that I was referring to. So we are basically using this formula here. So it has been simplified for us. There's that. So this is the estimated beta coefficient there, it's minus. So remember, it goes with its sign, minus 97.5. So let's put that equal there so that it gives us negative there. So we are dividing that by the standard error according to the formula. So the standard error for that is 2053. So what is our value? Our value is minus 4.420, right? 4.4203 etc. So the critical value now that's given. So we basically want to measure and see if we are exceeding that or we are not exceeding that. So we have our first value given. So first thing that we need to check now is the sign. So it's negative there, and then the critical value is also negative. So we are happy with that. And then now we need to look and see what direction that one goes. Right. So in terms of how much are we beating the threshold? Right. So if it's minus 4.42 hours has gone to minus 4.4203. So we've slightly exceeded that. We've slightly exceeded that. So under those circumstances, we therefore reject the null hypothesis. It's like you have passed, but you have passed with the 50%, 50.1, something like that. So this is the situation that we are seeing here. But if you round it off, you basically have pretty much the same amount there. Okay, so you are on the critical value. All right, let's do for the next one. We have again our 0.3547. We are dividing that by the standard error there, which is that amount. Let's do the division there and see 0.3547 divided by 0.0727, right? 0.0727. What do we get? 4.48. Oh, okay, no, it's fine. I think here, all right, I think here they were just giving us the calculations. Sorry, these are the calculations for that day. That's why we are getting all of them at the same amount. But I'm just going to show you now where we have critical values, how we apply. Suppose these are the critical values there. We'll basically be looking at whether these calculated t values exceed the critical value. I think let me skip that one because we'll basically be getting the same amounts there. Okay, these are the calculations there. Let's look at when we have critical values and see how we deal with that then. Okay, so the critical values are basically going to be determined by our levels of confidence, right? Let's look at the one-sided test there. All right, good. So we are going to be doing that there. I want to see what, all right, the critical values are. All right, let's see what we have here on critical values. Let me just run a calculation. All right, so suppose this is the critical value there, right? This 1.943. So, okay, it could well be what. So in this equation, though, for all three variables, so sometimes it's not exactly the same, but let's suppose for all three variables, the critical value is given as 1.943. So this is what we do now on the calculations. We'll then calculate these t values, which we are calculating previously, so which is 4.91. We divide them by, so this here in brackets is always going to be the standard error. So we divide that by the standard error. So this is going to give us 2.063 there. Right, so we get that for that one. So which is basically 2.1 there. So we compare that 2.1 in the critical error, sorry, in the critical value, right? In the critical value there, to see, right? To see if it exceeds. So in this case, 2.1 is greater than 1.9. So what do? We reject the null hypothesis, right? Let's do for the next calculation. 0.00123 divided by 0.00044, that gives us 2.79, so which is at 2.8. This is again greater than that. So what do? We do not reject the null hypothesis again, because we have passed, we've pretty much gone over that amount there. Yes. What about the next one? We have a minus 7.14, right? We are dividing that there by 71.38, so it gives us pretty much that value there, minus 0.6, so minus 0.1. So that minus 0.1 is less than that. Therefore, we do not reject the null hypothesis. So that's what they are saying there, right? Okay, so that's what you are getting there, right? So you can see for the first one, we are rejecting null hypothesis there because the absolute value of that is greater than 1.1, and again we are rejecting that there. So that's basically what we've been doing there. All right. So that's what we've been basically doing there. All right. Okay, then after that, we basically draw up our conclusions on that. So I think we'll pretty much now pick this up on the next session. I think on the next session, let me see if I do have the assignment open here. I'm not sure. Okay, I don't have the assignment open here. Let me see what we'll do. Okay, no, it's gonna be fine. It's fine. But I think by the time we meet for the next session, I think I'll just post the assignment. So the assignment, nothing to stress about on the assignments there. It's really not that hectic, right? So part of what we did here today, we'll be applying on the assignment.